Good morning everyone. I will be presenting Landauâ Lifshitz pseudotensor in the presence of cosmological constant. The mathematical expression for the conservation of gravitational field is not yet found in mathematical form, yet many attempts have been made in the past to find approximately any type of mathematical expression. So these are three main energy momentum tensor which are found, like energy momentum pseudotensor by Landauâ Lifshitz and energy Einstein pseudotensor, Bell-Robinson tensor. So this is the expression for Landauâ Lifshitz tensor. This expression is found by Landauâ Lifshitz. It has following properties: that it has been constructed only with metric tensor and gammas. That means it is purely geometrical in for origin, and it is symmetric in its index I and k, and when added to energy momentum tensor of mass or matter, the first derivative of total quantity is found to be 0. That means total energy momentum is conserved, which includes the energy momentum tensor of matter and gravitational field, and that it vanished locally in an inertial frame of reference, because in local frame gammas can be made to be 0. So this expression, which is found by Landauâ Lifshitz, does not include cosmological constant. We will try to incorporate cosmological constant in this expression. We start with the Einstein equation, including cosmological constant. So in the absence of gravitational field, the conservation of energy momentum of matter is expressed by the equation that covariant derivative of energy momentum tensor is equal to 0. Since covariant derivative of energy momentum tensor is equal to this, the total quantity has to be 0 in order for conservation to take place. But in this form, this expression does not express any conservation law because of this extra term here. This is related to the fact that in gravitational field, the form momentum of matter alone cannot be conserved. Rather, the momentum of matter plus gravitational field should be conserved. Okay, to tackle with this problem, we choose a system of coordinates of such form that at some particular point in space-time, the first derivative of metric tensor vanishes. So at this point, the second term in equation 2 goes to 0, and we have only simple derivative of energy momentum tensor equal to 0. So we have the conservation law here. In this form, Tik can be expressed to be equal to this quantity, where eta ikl is antisymmetric in k and l. So when we take first derivative with respect to xk, so this denominator becomes symmetric in k and l, and numerator is antisymmetric in k and l. So this quantity, the first derivative of Tik, automatically goes to 0. We will try to find this quantity eta ikl with the following method approach. So we start again with the Einstein equation, and we reduce the Ricci tensor and Ricci scalar in this form in local coordinate system, and we introduce a new term called zeta ikl of this form, and this has the property that it is antisymmetric in k and l, and its first derivative is equal to lambda gik. So we put the expression of Riemann Ricci tensor, Ricci scalar, and lambda gik in this equation, and simplifying after simplifying we found the expression of tik to be equal to this. This expression is so far exact up to here, but we use the assumption of local coordinate system, so we can take 1 upon minus g outside this derivative in local coordinate system, and approximately this expression is found to be equal to this. So we this is the quantity we assumed eta ikl earlier, and this is approximately equal to this much. So the bracketed quantity, let's say, as equal to del by del xkl hikl. So this relation is valid in this special coordinate system. When we go in other coordinate system, let's say this expression will not be equal to each other, and say the difference between these two quantities is equal to small tik due to gravitational field. So since the hikl is involved in this equation via simple derivative rather than a covariant derivative, the quantity tik is not a tensor quantity in its origin. After using the expression of hikl from equation 10 and tik from equation 4, we get this form of energy momentum tensor of tik. This the expression without a cosmological constant is the same up to here as found by Landauâ Lifshitz. So we found these extra terms which involves cosmological constant and gammas and metric tensor. This expression has following properties: that the total energy momentum of matter and gravitational field is found to be equal to the derivative of this quantity is equal to 0, so total energy momentum is conserved. And by choosing an inertial coordinate system, we can make tik equal to 0, because in inertial coordinate system gammas can be made to be 0. By choosing a curvilinear coordinate system in flat space-time, that is in the absence of gravitational field, we can make non-zero value of tik, and tik is can be seen to be dependent on coordinate system, and this expression is not symmetric in its index. Thank you.